वेलकम टू मैथ सॉल्यूशंस फॉर ऑल। आज हमने MT14 जून 2019 को एक क्वेश्चन को सॉल्यूशन से बताने जा रहा हूँ। बहुत ही इंपॉर्टेंट क्वेश्चन है। प्लीज़ लाइक एंड शेयर माय चैनल। ए ट्यूमर मे बी मॉडल्ड एज ए पॉपुलेशन ऑफ मल्टीप्लाइंग सेल्स. It is found empirically that the birth rate RT of the cells in a tumor decreasing exponentially with time, so that RT equals to beta multiplied by e to the power minus alpha t, where alpha and beta are positive constants. If Pt denotes the population of cells at any time t and P0 is the initial population, then formulate the mathematical model of the population of cells. Solve the model equation obtained in 1 above to find the population Pt and any time t. Interpret the behavior of the population based on the solution obtained and also find the limiting value of Pt as t tending to infinity. So, solution: let Pt be the size of the population cells at any time t. हम लोग मान लिया कि Pt be the size of the population at any time t greater than 0. Also, here it is given RT, the birth rate of the populations of cells, where RT equals to beta to the power minus alpha t. We assume death rate of the population of cells is 0. Under this assumption, the model differential equation is dpt by dt equals to death rate, birth rate minus death rate multiplied by pt. This is the equation. So dp by dt equals to b to the power e to the minus alpha t minus into p with initial boundary value p0 equals to p0. Solution of the differential equation dp by dt equals to beta e to the power minus alpha t p with initial condition p0 equals to p0. So dp by p is equals to beta e to the power minus alpha t dt. Integrating on both sides, we get log p equals to beta into e to the power integration of e to the minus alpha t dt. Log p equals to minus beta by alpha e to the minus alpha t plus c, where c is the integrating constants. And initially when t equals to 0, we know p0 equals to p0. We get ln p0 equals to beta minus beta by alpha plus c. C is just ln p0 by beta plus beta by alpha. Then from 1 we put the value of integrating constant c. So this we get this value after calculating lp minus ln p0 equals to beta by alpha. मैंने कॉमन ले लिया बीटा बाई अल्फा 1 माइनस e to the power minus alpha t. So by the definition of log property of log p by p0 equals to this, p by p0 equals to e to the power minus beta by alpha 1 minus alpha t. So we get pt equals to p0 into e to the minus beta by alpha 1 minus e to the power minus alpha t, where alpha beta are positive constants. This will gives the population pt at any time t. Now it is clear that for t tending to infinity, it is minus alpha t tending to 0. When it if we get here t tending to infinity, we know it is minus alpha t always tending to 0, and thus limit t tending to infinity pt equals to p0 into e to the power beta by alpha equals to kc. Now the question behavior of the population. From the equation 2, we can say that here the equation number 2, we can say that this is the e to the power minus alpha t, this is the decreasing term. So we get tumor grows more and more slowly with the passage of time. जब टाइम इंक्रीज कर रहा है तो जो ट्यूमर का जो ग्रोथ है, ट्यूमर पॉपुलेशन का जो ग्रोथ है वो डिक्रीज करेगा. दैट इज अल्टीमेटली अपोजिट टू द लिमिटिंग पॉपुलेशन p0 e to the power बीटा बाई अल्फा. तो यहाँ पे हमने एक कार्व ड्रॉ किया है pt वर्सेस टाइम t, पॉपुलेशन ट्यूमर का पॉपुलेशन pt वर्सेस टाइम t का एक कार्व है. जब यहाँ से ड्रॉ किया, यहाँ से स्टार्ट किया, ट्यूमर पहले ग्रोथ कर रहा है और जब टाइम इंक्रीज कर रहा है वो उसका जो पॉपुलेशन वो डिक्रीज कर रहा है. ये जो के किया है, के कैरिंग कैपेसिटी, के इज नथिंग बट कैरिंग कैपेसिटी ऑफ द पॉपुलेशन. This is the sigmoid curve. This is called the sigmoid curve. Thank you.